All right, so we've got our study guide. So this is for our momentum test. Just remember, if I'm going too fast or too slow, you can fast forward, rewind, whatever you need to do, pause the video, write down the notes. But you need to know this stuff for the test. So, inelastic collision, right? That's right here. Inelastic, they hit, they combine, and they keep rolling. So this is like a sticks together. Okay, right there. Elastic, right? They hit, and then they bounce away, right? So this is one where they bounce away. We're just doing nice, simple definitions here. So, a basketball hitting the ground and bounces back up. What kind of collision is that? Well, it's not sticking to the ground. It's bouncing, so it's an elastic collision. Baseball lands in the mud and sticks there. What kind of collision is it? I mean, didn't bounce away. It just kind of lands in the mud, plops in there. So it sticks together, so it's inelastic. All right. This question here, it says, if the putty in the inelastic collision has a mass of 2 kilograms and a velocity of 2 meters per second and hits the blue ball, which has a mass of 10 kilograms, what is the momentum of the bowling ball and putty after collision? Well, it looks kind of like an M1 V1 equals M2 V2 equation, but it's not. Why? How do we know? What is the momentum? It's not asking for a velocity or mass. So basically there's a collision and it wants to know what the momentum is after the collision. Okay. All right, so after the collision, what was the net momentum? So it's really a net momentum problem, right? Net momentum, also known as combined momentum. So we need to know the momentum of the two objects then, right? We have a piece of putty, okay, going this way. It's being thrown, right? If the putty in the inelastic collision has a mass of 2 kilograms, okay, so the putty's mass is 2 kilograms, right? And its velocity is 2, well, that's just our P equals M times V equation, right? So 2 times 2 is the putty is moving with a momentum of 4 kilogram meters per second, okay? And then there's another ball over here, which has a mass of 10 kilograms, but it's not moving, it's just staying still. So its velocity then would be 0, which means its momentum is 0. So it's just a 0. So you have your 4 minus 0, your net momentum is 4 kg meters per second, right? Just like that. You're not doing the M1 V1 equation because it's not asking for it. It's asking for the momentum after the collision. Okay, this one is also another net momentum question. This one's a little simpler. Ball 1 has a momentum of 10. Ball 2 rolling towards it has a momentum of 5. So, one thing I see people get confused at is because they're moving towards the same spot, they think they're going in the same direction, but they're not. This one is going like kind of east, this one is going west. They're going towards the same spot, but from different directions, so their momentum is being subtracted here. So it's 10 minus 5 equals 5. All right? Let's skip that one. A 120 kilogram girl and a 60 kilogram boy face each other on rollerblades and push off. The girl pushes the boy and moves away at 1 meters per second. If both kids have the same momentum, the girl's velocity is. This right here is our M1 V1 equation. We have all the things we need, and it's asking for the fourth thing. So the equation looks like this, M1 V1. So the mass of the first object times the velocity of the first object is equal to the mass times the velocity of the second object, okay? Now, the tricky part with these kind of questions is you've got to keep the objects together. If you pick the girl as object 1, the mass and velocity have to be her mass and velocity. You can't mix and match the girl and the boy's masses and velocities. So the mass of the girl says right here 120 kilograms. So write that. The velocity of the girl, that's a mass, that's a mass. This is a velocity. Oh, but the boy moves away at 1. So that's not this one, that's this one over here. And then it says, what is the girl's velocity? We don't know yet. All right, 120 times V. What's the mass of the boy? 60 kg. What's the velocity of the boy? 1 meter per second. right? So 60 times 1 is 60. So we end up with 120v equals 60, right? This is done. So what do we have to divide by? Well, we want the v by itself, so we want to get rid of this 120. Okay? That cancels. So v equals 60 divided by 120, which is 1/2, or 0.5. That's it. We know this one is different from the net momentum because it's asking for a velocity. It's not asking for momentum. That's how you tell the difference. This one here, if a 5 kilogram piece of clay hits a 15 kilogram ball at 5 meters per second, what is the combined momentum of the two? So look at that right there. It looks like M1v1. It's giving us all these numbers, but it's asking for the combined momentum. This is another net momentum problem. So we need to get the momentum of our object. So we have our clay, and we have a ball. Okay, so the clay, right, is 5 kilograms, so 5, and its velocity, right, so kilograms, well, that's kilograms, that's the kilogram of the second ball, so we don't worry about this yet, don't do anything with this, but the clay is hitting it at 5 meters per second, that's our velocity. So our momentum is our mass times our velocity. Just like on this one, you have to multiply the ones that are the same object. You can't do 15 minus 5 because the 5 is the clay and the 15 is the ball. They're two different objects, so that is not how you get their momentum. So 5 times 5 equals 25. Ball, 15 kilograms. Ball's not moving. We don't have a velocity for it. So again, 0. So 25 minus 0. At the end, the net momentum is just 25 to the right, like that. Okay? Two bowling balls are rolling towards each other with the same momentum. What is their net momentum? So another net momentum problem. They're rolling towards each other, right? We're going to subtract, because, right, this is going this way and this one's going this way, different directions. If they have the same momentum, well, this is the same as this. So if you subtract them, what is it going to be? 0. Easy, right? Free point on the test tomorrow, all right? Station 3. So this one, the equation you're supposed to write down was I equals force times, this is called delta T. So this is one thing. Delta T also looks like a triangle. We call it delta. So delta T is one thing. So the impulse is the change in momentum. Okay. The force is the force of the impact. So this is a collision. This is a crash. And the delta T is how long did it take for the crash to happen. So the impulse is the change in momentum. So if you're looking at two similar crashes, this doesn't change, right? It's going to be the same. So if you have a multiplication problem, if this is staying the same, how can we decrease the force? How can we get the force lower? Well, if we make the time bigger, right? If time goes up and this doesn't, this is the same. Well, the only way that can happen mathematically is if this got smaller. So the more time it takes, the less force you get hit with. We can show that. Let's say you get hit with 10 force, and it took 1 second to do that. Well, your impulse would be 10. Okay, so this is like, think of this as a car crash. You get hit with 10 force times 1 second, it gives you a 10 impulse. So again, second crash, still 10 impulse, right? Same car, same speed. But let's say you bought some airbags, and now your collision happened in 2 seconds, okay? What would your force be? Your time went up. It took longer for the crash to finish. Well, impulse is the same. This went up. So how do we get our force? Well, divided by 2, our force would end up being 5, okay? So when this went up, this had to go down to keep this the same. That's just how the math works. So how would that work for catching a water balloon? Well, you kind of do this pulling back motion, right? Like when you catch it, you don't just hold your hand and hit. You kind of catch and then like lower it. When you do that, you're taking longer for the collision to finish. So if it's taking longer for the collision to finish, there's less force on the water balloon, so it's less likely to break. Okay? And that's it. You just need to know for this equation that more time means less force on the impact. Right? So when you do that with the ball, what you're doing is increasing the time, which decreases the force. Right here. So station 4, we're doing this P equals mv, right? This is your just basic momentum calculations. Momentum is P equals the mass times the velocity, right? So this one says calculate the momentum. So we know what we're going to do already, right? We're going P. So mass times velocity. That one's easy. 1,200 times 20 would be 12,000, 24,000. And that's it. Simple. Multiplication. All right, next one. What is the momentum of a child and wagon if the total mass of the child and wagon is 24 kilograms and the velocity is 1.5? So child sitting in the wagon, they're both moving, so their momentum is the same. So we don't know P, so we have a mass here, 24, right, because of the kg. And we know the velocity is 1.5 meters per second, so it's times 1.5, which would be 24 plus 12, which is 36. Just simple multiplication. All right. Parking brake on a 1,200 kilogram automobile. Kilograms. Okay, we have mass. And the vehicle has reached a momentum of 7,600 kgms. Okay, so we have momentum, and it's asking for velocity. Now we got to do a little bit of algebra. We know the momentum, right? We know that it's 7,600. Says that right in the problem. We know the mass is 1,200. We don't know the velocity. Well, we can just get it by itself by getting rid of this 1,200, right? Just divide by 1,200, both sides. This cancels, and your V equals, I'm going to do this on a calculator real quick. That's a weird number. 6.3. So your velocity would be 6.3 meters per second, okay? So we knew what to do because we just followed this equation. This one, toy dart gun generates a dart with 0.14 kilogram meters per second of momentum and a velocity of 4. What is the mass of the dart? So we know momentum, so let's write it down. 0.14 equals, we don't know the mass, so we'll write an m there, times the velocity is 4. So what do? Just divide by 4. Get that m by itself. Inverse operation. And whatever that, I think it's 0.035. So 0.14 divided by 4, okay? All right, last set here. Does net force cause speed or acceleration? Well, forces cause acceleration. They cause things to get faster or slower or change direction. So if an object is floating in space, how much force does it need to keep going the same speed? Well, if it's already moving, it doesn't need any more force to go the same speed. It would need 0 force. The only time you need force is if it's not moving and you want it to move, or it's moving and you want it to move faster. So 0 force. You don't need any. It's just moving the same speed. If you throw a baseball in space, it will keep moving forever in the same direction at the same speed, unless something stops it, like it hits a planet or a star or something. This one, again, probably should be a free point on the test tomorrow. You have 15 Newton falling object, 7 newtons of air resistance, magnitude of the net force. Different directions, 15 minus 7 equals 8. Two objects rolling down a hill will have the same speed, so when would they have different momentums? So if a hill doesn't have any friction and the objects are rolling down it, they're going to have the same speed. That's how gravity works. So if they're going to have different momentums, well, if they're going the same speed, there's only one way they can do that. If one object's like bigger, right? Like you have a boulder like this big and a boulder like this big. They can be going the same speed. Well, this one has more mass, more momentum. That's it. Will an object with a constant net force change momentum, velocity, or acceleration? Well, we just said that net force causes things to accelerate. So that's a check mark, yeah. Acceleration will change. Well, what is acceleration? It's gaining speed or losing speed. Well, that's your velocity, right? So the acceleration means your velocity is changing. So let's do a check mark there. And then velocity, right? Momentum is mass times velocity. So if this is changing, your momentum's changing. All three. All the above. That's pretty much it. Good luck. Oh, and don't forget to like and subscribe. Thank you.